And thank you very much, Beth, inviting me. And first, I would like to introduce Terastructure. Terastructure is me and my husband, Nathan. Before I started to say anything about Terastructure, how we started, and how we launched, and how we needed to change our path and what we learned, I want to start with a conversation going on LinkedIn and on the data science environment, that we say 90% of the world's data created in the last couple of years. The data I'm going to talk about is old data, but this is massive amount of data, and it is created in every single university that you know of. Anyways, I will start to give you an idea who I am and where Terastructure came from, and the real heroes in this journey that we took. One is my husband. He was always there. He was always feeling the pain. And my PIs and the angels actually invested in this company. So I started my career 20 years ago, almost, as a data engineer. It was not called data science at all. I was developing algorithms for NATO, basically fingerprint recognition, from fingerprint recognitions to landmine detection, more exciting projects like the flight simulation, aircraft modeling, as well as friend or foe firing models. So last 2 years of my career in that company was mainly on the business side. I think some of the business aspects I got from there, but when the money is not your money and the investors were already investing on that, which was NATO, it is different to be on the business side. So I learned it much later. When I was closer to my 30s, I decided to change my direction. It was because I was told that I have a brain tumor, and it didn't take too long for me to decide, okay, I'm going to use all my data skills to understand what's going on in this complex data, because brain is one of the most complex data sets that you can imagine. You can look at the brain, and you can predict the behavior. You can look at the behavior, and you can tell stuff about the brain. So it was so exciting for me, and I always loved the complex data. So in 2004, going back, it didn't take too long for me to put my backpack together and left Turkey, which is my country, to the Netherlands, where actually I met wonderful scientists. One of them is my PhD advisor, Dr. Avishai Hennick. So I learned how brain works, how it looks, what is the psychology, how you can stimulate the brain using behavioral techniques, developing tasks or paradigms. It was 2 years later. It was time for me to look other directions, because, as I said, my interest was always data. And the department I was in, mainly on the cognition and behavior, my advisor again came into play, told me that there is a unique center, which was in the US, and I never thought myself being in the US until 2006. So sure enough, I moved to US. This is a very unique center called Complex Systems and Brain Sciences. They don't only teach the brain, but the complex data, for example, hurricane modeling, predictive analytics of the wind directions, wavelengths, those models. So meanwhile, I kept Avishai as my advisor. Today I don't even know whether it was a good idea, but I started to feel the pain when I was there because Avishai was not next to me. He was not sitting next to me. He was there in his very nice office in Israel. I also had a very nice office in Florida, and I could also walk to the beach from the school. So the phones and emails and Skype messages fell short. I needed his attention. As a Nobel Prize winner professor, he had more than enough students to take care and work with. So I used to actually copy my brain images on the Word documents and write what I am doing and then send it to him. Sometimes I received messages from him saying good or bad, or most of the cases, nothing. The professors are very, very busy. If you are not in front of them, they will forget about you easily. And walking around the university, meeting new people, I heard a lot of horror stories, and I was happy that I was not alone, so I could relate my stories, not being able to graduate soon enough, and all kinds of stories. Hearing from friends helped me a lot. So my office mate, he was getting ready for graduation. He got a date to graduate, but all of a sudden his professor asked him to go and check his data for something else. And then he goes, he checks his data. His data was not there. Somebody removed it accidentally on the MRI server. It was sad enough that he had to redo the study, and 8 months later, he graduated. And another story that I love to tell everybody is about the server issues, because there is a professor, I'm talking about 2008 and 2009. This is the time that everybody wanted to get grant money. Everybody wanted to publish. It is still publish or perish. So you gotta do your research fast enough. You gotta have your data. You gotta write, and you gotta get your money. So Dr. Bressler is one of them. He was working on monkey data, and when you look at US is the heaven for the monkey data because of the IRB rules and everything. It was not strict enough. So he had terabytes of data, but we didn't have wet lab in Florida. The wet labs he was working was in Montana. So he was sending his hard drives to Montana to get the data. And then he was using like thumb drives and all kind of different stuff. He got $500,000 for his research. Good enough. He goes and buys a couple Linux servers. But do you think he has anybody to take care of those Linux servers? He's a psychologist with some computational background. He didn't have anybody. He put all those Linux servers. He was so happy. He let his students to put the data on. It didn't take for hackers to find out that he doesn't have any security protocol running behind. So he lost all the data. His computer was hacked. His system was hacked. But still, he had the happiest students because he gave those servers as the PC to his students. So they had the powerful computers to use their entire PhD. So spending time and money on algorithm development is the biggest problem in science nowadays, because you don't really have somebody to develop your algorithms. I mean, there is, if you are computationally savvy, you don't want to stay in academia. So most of the people staying in academia would be cheaper power. Everybody says cheaper power, but the people with the computational background or who are interested in this side of computers, they don't stay in academia. So it takes, and hiring those people is not that cheap, so you spend a lot of money. And the other issue there is misplacing and changing the data. So most of the cases, the students put the computer from data from one computer to the other, and they forget where they put the data at the end of the day. And sometimes they also change the nature of the data when they are playing around, even without knowing. They try to clean the data. They lose a reference point. And it happens all the time. And as I said, the server issues is the other problem. I mean, there is no enough human power to run the servers in the universities. There are a lot of crashing, virus issues. Everything is so slow. And the biggest problem, not seeing the actual data in a publication. So you collaborate with somebody in Israel, like my case. My advisor never saw the actual data in our publications. If I were to falsify my data, he would be the victim of my falsification, because we have names under same publications. I mean, 2 years ago, this famous professor, his name is Stoppel, he was a Dutch professor. He said that meat eaters are barbarians, because he figured this with his surveys and the studies that data he collected from people. So 30 years later, one student figured out that he was actually writing those surveys by hand, hundreds of surveys by hand, and changing the nature of the data he collected. He had to give back not only his titles, but his degree. And the people who wrote with him was the victims of his crime. So all those papers were withdrawn. All those people lost their jobs because they didn't see the data. They didn't know what was going on out there. Okay, all those things were going along. We knew all those problems out there. And I was coming and crying to this guy every day, over 6 months. Because these things change your life, and not being able to graduate, I mean, I always call PhD is a psychological battle. And if you see all those cases around you, it really affects you badly. And he's the one telling me, okay, if you have that much of data, why don't you put it on a cloud platform and analyze it without downloading, and interactively collaborate with your remote coworkers? It was good enough. Did I listen to his suggestions? Yes, but I was so busy to graduate and leave Florida. Florida was wonderful, but if you are a PhD student, you don't really want to see anything. You just want to finish and start a new life and make a little more money, become a postdoc. It's not a lot, but a little bit more. So without we knew it, we moved to North Carolina. It was, and I was too busy to start my new lab. And my new lab was a little more exciting than my former. So I worked with the infants. And it was unbelievable hours and schedule. I was trying to get my collaborators together, get some new guys. At the same time, my PhD advisor my postdoc advisor was trying to find a way to build a platform together that he can really reach out and collaborate with them. So I told him what we have been thinking and how we can leverage his data and his collaborations. And he said, okay, and we started to brainstorm how we can actually figure out, this was my problem, this was my advisor's problem, and I heard stories around me, but we wanted to reach out more people. So we started to discuss about the possibilities. I went to the business school. We went to the business school. We started to develop a survey. We wanted to know who our customers were. So I think for the startups, if you are starting for a niche company, the surveys are so important. So you want to know who your customers are, what they are using, and what are they missing. So these questions we gathered together and then sent out surveys. And we figured that these are some survey results. And most of the customers in this business use MATLAB, and Python is very new to academia, but they quickly started to adapt that. And the other group of scientists, especially Python, since it was started by a Dutch developer, Python is more common in Europe, was more common in Europe than here. So in academia, they didn't even know what Python is here, but in Europe, they started to use it pretty early. So we got a lot of positive responses about Python being the part of this project. So as I said, some people knew what it is, some people didn't know what it could be. So we had two different customers. One is the younger professors. They are more interested in computers. They understand how it works. And the other ones are the scientists who don't want to worry about the analysis, what is going on behind the scenes, but they want to say, okay, this part of the brain took role of this, or that part of the brain did this. So they are more interested in the findings. Again, we identified 4 big pain points that we wanted to address using my experiences, my PA's position in this business, and surveys results. Always the data gets misplaced and data get changed, spending time on money algorithms, and being able to see the actual data before the publication is going to give a big relief to the professors and the server issues. So they can just store their data on the cloud platform, and whenever they need it, they can share and collaborate with their remote friends. So here the Terastructure started. It was going to be a web-based platform as a service, terabyte scale of data processing, allowing the real-time collaboration. If I'm sitting here and you are sitting in New York, and if it is very important to get together right now, you can get together on this platform. And the other problem is that these are patient data or participant data that you don't want to share with people who are not qualified or who didn't sign the security protocols or IRB protocols for this. So this secure cloud platform was so important to start with it. And also, we got an idea of who we are dealing with. We got these numbers using the LinkedIn groups, forums, user forums, as well as friends and collaborators. And here, actually, we can segue to our demo quickly. And then I'll tell a little bit more about the business model. So as I mentioned, Terastructure is a web-based environment. And here, the data is electroencephalogram data. It was collected in Holland. And these are these patients are very rare. This is called dyscalculia. And some people suffer from issues with number processing. So they look normal to you, but when you come with the numbers to them, like what is 2 plus 2, they will become dyslexic or autistic. So this is the data collected from them. These are the different brain locations of these people. And here we're quickly gonna plot a couple of electrode locations. This is basically for the scientists to see what is the difference, what's going on in the brain. And here we used SciPy toolboxes, just to start with. And we are using a method called principal component analysis to analyze the data to this point, but we are not going to show it here. It's going to take some time. We're just going to show you how we label and how the scientists can process and interpret the data. Basically, what he's doing is that he's showing the center parietal part of the brain, and we are going to look at the different patients and different groups, how it looks in this plot. And usually this is a luxury when you are working in a lab. You only have the opportunity to use MATLAB or EG lab, and you're limited to see different angles. And this part of the screen keeps your data, and this cannot be changed by the users. This can be changed by the owner of the data, whoever the member for this platform. These are basically the codes that we used, but currently we only have NumPy. And this is where you're going to see the plotting right now. And it is very simple for people who really don't want to deal with any algorithm development or don't want to understand what's going on behind it. So here you see two different. This is the same part of the brain activated, and these are the two different numbers that they are actually looking at, and then these are the two different plots that the brain is responding. So this is a very important part for the professor or a scientist, because they will see that something is happening around 3 milliseconds after the process happened. And this is very clean data. How are we going to go? Okay, after we had our first minimum viable product, we also dreamt about this opportunity. We looked at the market size, how much money we can make, and how much we need to charge for the membership. And it's quite a bit, it looks like a big market, but when you go out and try to ask for the money for the investors, this is not enough to wet their mouth for this. And the business, by training, I was a scientist. My PI was a professor. He was a scientist. So do our customers, do the customers. And we thought, why don't we go and ask for money from the government? So government, NIH has a particular grant for the startups, which is called SBIR. And you can go and apply for the money. So it was going to be our seed money. And as I said, we worked on the membership model. So the first level of scientist buys this system and then uses and shares with the collaborators. And the collaborator finds the system awesome and then comes back and buys another membership. And we also looked at the sales partners. Since I was in the business for 10 years, I knew who would be the sales partner, because you need to find somebody that everybody can trust in the business. But you don't want to put a lot of money in your sales or marketing, because you have limited seed money. So the best way, if you are dealing with a niche market, is to go with an established company and ask them whether they could be your sales partner. So the Brain Vision LLC was very nice to accept being our sales partner. And this is also an important chart. So we looked at our place in the market, so how where we were standing when it was compared to the others. And also, we worked on our napkin model of financials. Of course, I'm not going to show all those Excel sheets, but there's a deep arithmetic behind it. You need to know what is your operating costs, how much money you are paying on the servers, and how much money really is going to be enough to start and take you up to the point that you can make some revenue. And also, if you ever went to the VCs, they want to see your acquisition model. So there are 3 models in the market nowadays. It is go big and get bought by a giant in the business, and you're going to be on the headliners. Or another model is the startups. So startups can buy other startups to get bigger and have better place in the market, or remain small and enjoy the journey. So you can be a niche company. You don't make $1 million, but you can make good enough money to keep you going. And then we were fortunate enough to find some users around UNC. It's some more work, but most importantly, we couldn't really pass the death valley of the startup. So we stopped there because life took over. We had to do other stuff. But we learned a lot from this experience, and I still use the Terastructure for my consulting job. So Terastructure is not that, but doing something else. And 2010 and 2011 were a little early to come up with this idea, because the time is evolving so fast nowadays in the internet technologies. But in 2010, the cloud platforms were not widely discussed. It was started to be discussed, but it didn't trickle down to the market that we were really targeting. The professors were coming out of the sequester. They really wanted to go fast, but at the same time, they were so afraid of being scooped. So they didn't really want to go and open up to this unknown cloud environment. And I think it was partially my mistake that I didn't understand the customer above and beyond the survey. I was so excited. I mean, I was so, still I'm very angry because there is this huge amount of data. It comes out of their ear, and it is unrespectful for the participants and patients that we don't really have any results. We lose those different data sets in different places. Some of the data sets sit on old sun system, huge old sun systems. I don't know whether they will work or not. And you also find, if you ever had, I mean, anybody, did you ever met a PhD student talking about a thumb drive that they kept after they graduated? So I have some of those. I still think that I could one day analyze my data. So I was just so angry, and I really wanted to do something with that data. It's also the money. I mean, I'm trying to do a research. For example, I'm trying to do a research here in the US, and somebody else did the same research 10 years ago, maybe somewhere in Europe, somewhere in Australia. And that data, they didn't get to the point that they can analyze that data. So the data is sitting there. I'm trying to do the ABCs of the same thing. It is time, money, everything involved. But unfortunately, I didn't understand the professors that they really didn't want to come to that point. So I just took to part what they said. Okay, this is exciting, but I didn't want to hear the demand part that they didn't really tell me in those surveys. The other problem is that, I mean, neither of us is good networkers. So we didn't network with anybody. We didn't even go to the VCs or investors. We were just so attached to this idea that we are going to get the seed money from the government. So networking is the key. And there are a lot of other models actually that we could look for. One is the crowdfunding, crowdsourcing. You all do crowdsourcing. You are, I mean, you have GitHub account and you involved with the projects and stuff like that. Honestly, I'm doing one of those. I think it was a learning experience for me. I'm working for a company called Rare Genomics. There are almost 500 people working for this company all over the world. None of us gets a penny, but we involve in putting together the rare genetic disorders together, analyze the data. I'm leading the cloud part, so we pull this data on a cloud. We have patients in China, we have patients in Australia, and we work nights and weekends. And I didn't know it could be so fulfilling and it could make people going without the money. So I think crowdsourcing is a great idea nowadays, but I didn't know it back then. And one more thing that we never discussed about that value of the startups, the time that you don't have any money coming in the company, but you need to get going. So that part is very important, and we didn't discuss that emotionally and financially. It is a very hard process, and you need to prepare yourself in the beginning. Okay, this was the part of what I felt, how we try to deal with this problem and how we try to attack this problem. But now, forget about everything and just remember this part that I'm just gonna tell you right now, and take home, use it differently, try to understand different ways. I also write these things on the LinkedIn, so you can go back, find me on LinkedIn, read these things, and then you can say you're stupid, or you're silly, you couldn't do it, and we will do it. I'll be so happy to hear when you succeed on this. So first thing first, need and demand are two different things. They are not the same. I mean, literally, they could sound like the same, but you need to go have water, right? But you can sit here until I finish talking, or go hours and maybe a couple days without having water. The moment that you really need to have that water, you feel like you're dying, cannot go any further, it is the demand. So when you are getting into the business, you gotta wait until that point that your customers, prospective customers, really, really need that water. Patience is the key when it comes to this demand and need balance. And there are three right things: time, place, and persons. So sometimes you think that the market is ready, but it might not be ready. Everything might be saying that, okay, everything is ready, we're ready to go. But that's a very thin line that you need to realize. And the place. When you are starting your business, when you have your alpha and beta users who are going to be your advocate, they are going to tell people that you're wonderful. You got to be close. You got to see their emotions closely. You got to exchange ideas, feelings every day in order to succeed. And the persons in the aspects of networking. So go out, network, find people. I mean, investors and VCs want to give their money to the people that they know, and the prospective customers are gonna buy the product from somebody that they know. So go out and network, but don't get me wrong. So there is networking and networking. So I am not telling that you go out, smile, handshake with everybody. That's not it. It's just do your study, find right people, and then go meet them. Don't be shy. I have an advisor I complain to all the time. He became my lifelong mentor, and there's one thing that he tells me all the time, and sometimes I feel like I'm impatient not to hear him, not to listen. He tells me I'm going to go out and meet 100 people. If I get help from one person, I'm going to be so lucky. But there is no point in the earth sitting there and complaining that I'm not getting enough support, because nobody knows you're there. And also the other thing I want to say, full-time versus part-time entrepreneurship. I mean, startups are never part-time. You cannot be part-time in a startup. The time is very flux. You don't go there at 8 a.m. and don't leave at 5 p.m. You will have a lot of time that you spend there. You cannot just have a second job. I understand. I mean, I didn't have money. We didn't have money. So it's luxury to have money to run this company, but run any company. But one thing I hear a lot, it was not very common maybe 5 years ago, is a full-timer, this designated full-timer for a company. So everybody else chips in. One person works full-time for the company, and I call it full-time driver. So the other chips in, and that person drives the company. And the other thing is, of course, as I said, money. So sometimes you gotta love ramen noodles. So you will have a lot of nights that you are having that. So one day I was at UNC, a student was talking, and he was somewhere else. He was studying for GRE, and he didn't leave his little room. So he ate ramen noodle, and he peed in the cup of the ramen noodle that he ate. So you will have times like that. So you love the ramen noodle. Again, the exit plan. Go large or stay small. Oh, man. So we could all become Facebook or Google. Wouldn't be great? Making money, having a lot of stocks. That's one way of going. The second way is getting bought by companies like IBM or Microsoft. These are big companies, and it's wonderful. So you're going to be headliner of all the news. We all want to do that. And all the VCs are going to be waiting for you to give their money. They will line up. But the third model is, I think I like the third model better. It's a small niche company model. It will give you enough money to be comfortable. And you will most likely get your startup seed money from angels, basically friends and family. But that's a very stable way of going that. And I guess this is all. Oh, no. This is not all I can tell. I just want to have some fun with my talk. And this is one thing that I love. I took it on LinkedIn. And I really like this. I cannot get enough of this reading back and forth. This is not only for big data. It is the same thing for the startups. It's like you don't know it. Nobody else knows it. And everybody claims that they are doing it. So pick your weapon, attack it wherever you go. You have your tool, Python. You have different ways of attacking it. You can go crowdsourcing. You can do bootstrapping, or you can use every single penny that you have to start your company. So my suggestion is go start your journey and don't think about the destination too much. Thank you. If you have any questions.